So now we're going to solve compound inequalities. So we're going to take our same ideas from graphing, except for before we can graph them, we're going to actually have to solve the problems. So if you look at this first one, it says -4 is less than x minus 2, and x minus 2 is less than 3. So before I can graph this, I actually have to go in and get the x's all by itself. So I'm going to use my same skills that I know. I'm going to get rid of this -2 by adding 2 to both sides. When I add 2 to both sides, I'm left with -2 is less than x. And I don't like when my x is second, so I'm going to switch it around. X, -2. I see that the sign is pointing at the -2, so I have to make sure it still points at the -2. And now I've got my first answer. I'm going to solve the second one to get my second answer. So I've still got to get rid of the -2. I'm going to add 2 on both sides. When I add 2, I get x is less than 5. My x is on the left, so that one's done. And now I notice it's also asking me to graph. So I'm going to draw in my number line. I'm going to bring down my -2 and my 5. My -2 gets an open circle because it's got a greater than sign. And my 5 is getting an open circle because it's a less than sign. And then I see it's an and problem, so I know I have to shade what they share. And since I want numbers that are greater than -2 and less than 5, I want everything in between. So it's the same idea as last class. We're just adding in the solving step. So first you have to solve both pieces before you can just graph them. So you try this next one. 5 is less than or equal to m plus 4, and m plus 4 is less than 10. I would pause this, give yourself a second to try it, and then check your answer once you're done. So the first thing we need to do is get rid of the 4. So I'm going to subtract 4 on both sides. And that leaves me with 1 is less than or equal to m. My m is on the wrong side, so I'm going to flip it around. I've got m. My sign still has to face the m, and 1. So m is greater than or equal to 1. Oops. We gotta solve the second one, so I'm going to subtract 4 again. And I get m is less than 6. So now all I need to do is graph it. So draw my line. I'm going to bring down my numbers. I got a 1 and I have a 6. My 1 isn't equal to, it's greater than or equal to, so it gets a closed circle. The 6 is just a less than sign. There's no equal to, so it's an open circle. I notice it's an and problem, so I know I need things they share. So I need numbers greater than 1 and less than 6. So I need the numbers in between. So now you know that us mathematicians don't like to write things more than once, and I noticed right off the bat when I was doing these problems that I had an x minus 2 in both of them, and I had an m plus 4 in both of them. So instead of having to write those twice with the and in between, we can use our idea where we rewrite our inequalities. And I can say -4 is less than x minus 2, which is less than 3. And I can write that entire problem all smushed together. It's exactly the same thing as the one that's above it. They just kind of smushed it together so that they didn't have to write the x minus 2 twice. They didn't have to write the and. It's just simpler. It's less writing. So you can, anytime you see a problem that looks like this, you can always rewrite it as two separate pieces to make it look like the first one. Or you can solve it all at one time. So I notice right off the bat, I need to get the x by itself. That means I need to get rid of that -2. So I need to add 2. Now, whatever I do to one side, I have to do to all sides here. So I'm going to add 2 to both answers. Add 2. I have to make sure I add 2 to both of my answers because just like in the first example, I added 2 on both answers on both separate problems, so I need to do it everywhere here. So once I add 2, then I get -4 plus 2 gives me -2. I'm just going to bring this sign straight down, less than, bring the x down, bring this sign straight down, and 3 plus 2 is 5. And now there's nothing else I need to do there because my x is all by itself. It's all alone. There's nothing else I have to do. So I can just graph my answer here. This is my final answer. It says x has to be in between -2 and 5. So if I'm graphing that, remember I'm bringing down the -2, I'm bringing down the 5. They both get open circles because they both aren't equal to. And I want the numbers in between. I want x to be in between, so I'm shading in between. So you try and solve 5 is less than or equal to m plus 4 and less than 10. You should get the same answer as the problem above. So pause it, try to solve it, and then check yourself. So since I'm solving this all together, I need to get rid of the 4. So I'm going to subtract it to both answers. I subtracted, ooh, hello. I want to cancel my 4s, not my answers. Cancel my 4s. Then I'm going to bring down my answer. 5 minus 4 is 1. Bring my sign down, less than or equal to. M, bring my next sign down, less than. 10 minus 4 is 6. And I see that I got the same thing that I got up here. It's just written all together. So I'm going to go ahead and graph it. I'm going to bring down my 1 and my 6. My 1 is going to get a closed circle because it's an equal to. My 6 gets an open circle. And I want the numbers in between. So I shade in between. Now let's look at an OR problem. So an OR problem we know is always going to say OR in it. And basically all it is 2 problems together in one. So we're going to solve each of them and then graph them. So if I look at that first one, 3y minus 5 is less than or equal, or it's just less than, -8. I need to get rid of the 5. So I'm going to add 5 to both sides. I'm pretty much just going to ignore the other piece, and I'm going to solve that once I'm done with this one. So I get rid of my 5s. That leaves me with 3y is less than -3. Now I've got to divide by 3, which leaves me with y is less than -1. I didn't flip the sign because I didn't divide by a negative number. Both sides I divided by +3, so I didn't have to flip the sign. Then I have to solve the other problem, so I look at the second one, which says 2y minus 1 is greater than 5. So I'm going to add 1 to both sides, which gives me 2y is greater than 6, and then I'm going to divide by 2, which gives me y is greater than 3. And the last thing I need to do is graph my answers. So bring down my -1 and my 3. They both get open circles. And I need y to be less than -1, so numbers less than -1. And I need y to be greater than 3. And now I'm all done. You try 2p plus 1 is less than -7, or 3 minus 2p is less than or equal to -1. Once you're done, unpause the video and then check your answer. So the first thing I'm going to do, subtract the 1, which gives me 2p is less than -8. And then I'm going to divide by 2, divide by 2. I get p is less than -4. And I didn't have to flip the sign because I divided by a +2. So next I'm going to subtract 3 from the other problem. Subtract the 3. I bring down my -2p is less than or equal to -4. Then I'm going to divide by -2, divide by -2, which gives me p. And now this time I do have to flip the sign because I divided by a negative. And -4 divided by -2 is just +2. So I get p is greater than or equal to 2. And I have to graph it. When I go to graph it, I'm going to bring down my -4. I'm going to bring down my 2. My 4, it's an open circle. My 2 gets a closed circle because it has the little bar under it. It has that equal to. And then I see that I want p to be less than -4. I want p to go this way to the left. And I want p to be greater than 2. So I'm going to the right. Once I have my graph, I'm all done. So let's try one more together before you go off and work on these on your own. So this next one, example 3, says 5 plus x is greater than or equal to 29, and 3x is greater than 36. So I'm going to solve them, even though it's an and problem, I'm going to solve them separately because they gave me 2 separate problems. So the first thing I'm going to do is I'm going to look at that 5 plus x is greater than or equal to 29, and I'm going to subtract 5 from both sides. And when I do that, I get x is greater than or equal to 24. My x is all by itself. It's on the left side, so I'm good. My second one has 3x is greater than 36, so I got to get rid of the 3. I'm going to divide, and I get x is greater than 12. So now when I go to graph this, Remember with my ands, I have to have only what they share. So when I put 12 on here and 24, I notice it's saying x has to be greater than or equal to 24. So greater than or equal tells me close circle, and x has to be greater than 12 tells me open circle. Now normally my ands shade in the middle, but they're both in this situation greater thans. They're both going to the right, so I can only shade where they share. So I'm only shading over here because this is true for both of them. It has to be greater than 24 and it has to be greater than 12. So numbers like 13 and 14 don't work because they're not true for the first part. So I can only shade over here. So you're not always going to be shading right in the middle. You have to make sure you check your signs because sometimes it might be a little strange and you might only be shading part of the graph. All right, you try x divided by 5 is greater than 4 or 2x is greater than 20. In order to solve this first one, you're going to multiply by 5, which leaves you with x. X is greater than 20. X is all by itself, so that piece is done. And now I'm going to solve the second part. I've got to divide by 2, divide by 2. When I do that, I get x is greater than 10. So now I have to graph it. I'm going to put my 10 down and my 20. They both get open circles. And then I'm looking, okay, I need numbers greater than 10, so I'm going to the right, and I need numbers greater than 20. But because this is an OR problem, when I shade this, I can shade everything to the right of 10. And notice I go right over my open circle because I can shade everything to the right of 10, even though 20 isn't included in x is greater than 20. It is included in x is greater than 10, so I can shade both of those. I can shade right over that open circle. I can shade everything to the right because it just has to be bigger than 10 in order to make one of them true. So all of those are my possible answers.